Our oceans provide food and jobs for millions of people, but they're facing unprecedented challenges from overfishing to climate change. These pressures threaten both marine ecosystems and the communities that depend on them. To make better decisions about fisheries, policymakers need tools that can tackle their complex nature. Just like mosaics are more than a bunch of colored tiles, fisheries are more than just fish and boats. They're systems where human actions, environmental factors, and marine life interact in unpredictable ways. Traditional models often fall short because they don't capture the adaptive nature of fishers, making it tough to anticipate the long-term outcomes of policies. That's where agent-based models come in. ABMs, for short, simulate the actions of individual agents like fishers and how they respond to different policies, market changes, and environmental conditions. Here, we are introducing Poseidon, an ABM specifically designed for fisheries. Poseidon was born in 2015 at the University of Oxford. It's been developed in collaboration with Ocean Conservancy and other partners. We began by focusing on conceptual scenarios. By making our agents just smart enough to apply simple strategies, we were able to have them adapt to fishing regulations in realistic ways. For example, they start racing to fish when the season is shortened, or fishing the line when a marine protected area is introduced. We then applied Poseidon to real-world fisheries to help address concrete management challenges. In California, Poseidon was used to model how fishers in the West Coast groundfish fishery would react to new regulations like individual transferable quotas and bycatch restrictions. In Indonesia, Poseidon was used to evaluate the scale of the interventions that would be needed to help rebuild stocks like Malabar blood snapper in the Java Sea. Poseidon is now being used by the Inter-American Tropical Tuna Commission to study the impact of fish aggregating devices, or FADs, in the Eastern Pacific Ocean. The model shows that limiting active FADs by about 20% could significantly reduce environmental impacts without harming overall catches, a win for both sustainability and economic viability. Fisheries have many layers, and Poseidon represents them all, but where it really shines is in its ability to model the fishing fleet in as much detail as is available about it. It also allows you to define regulations in a very flexible way, making it possible to explore practically any policy scenario you can imagine. On top of that, agent-based models are fully observable. You can track high-level statistics like total landings or fleet profits, but you can also follow the behavior of individual fishers and see how regulations affect them. With the SURIMI project, we're taking Poseidon to the next level. We're making it more robust, easier to use, and we're integrating it with the digital twin ocean infrastructure. We're also building bridges with EcoPack with EcoSim and other SURIMI models, aiming for all of these to be used together for management strategy evaluation. It's all about helping to create policies that balance marine conservation with the needs of fishing communities, ensuring the future of our oceans and the people who rely on them.